Hello and welcome to Calculus tutorial. We are going to continue our look at differential equations. So last time we were solving them using separation of variables, and something very similar, pretty much the same thing as solving, is this idea of slope fields, something you've probably never heard of. It's actually pretty cool. It makes some amazing graphs, and that's essentially what it is. It's a graphical representation of solving a differential equation. So let's take a look at what a slope field is. So we're going to take this differential equation. Let's solve it by hand. This is a nice and easy one. Separate the variables by multiplying by dx on both sides. We're left with dy is equal to x squared minus 3x dx. Take the integral of both sides. You're left with y is equal to 1/3 x cubed minus 3/2 x squared plus c. Now I don't have enough information to solve for c, but the only thing c does is shift the graph up or down. It still has to have a slope described by this equation. That has to be its derivative. And so what we're going to do is we're going to take all of these equations and we're going to start plugging in numbers for the plus c. So here is what that can look like. There is our equation graphed, but we don't know what the plus c value is, so we don't know how high or how low this graph should be. Should it be way up here? Or should it be way down here? We don't know. But what they do have all in common is they're all the same basic shape because they have the same slopes. And so what we do is we can create what's called a slope field that shows all of them at once. And so we draw little lines everywhere that mimic the shape or the slope of the graph. So you can see how these lines fit the graph perfectly where they touch. It doesn't matter where I put the graph. They always show the slope or the shape perfectly. And so if I take the graph away, because we don't know where the graph actually is, we're simply left with what's called a slope field that shows the general shape of the solution curve. And hopefully, if you kind of unfocus your eyes, you can still see the general shape of what this should look like, depending on where it is, how high or how low. And as soon as you know just one point that you could plug in, so I'll put, say, a point right here, we can then find the solution curve that would fit that point. Here, I'll show it to you graphically. If I can go high enough, right there. There's only one that will do it. And then you could solve for c and know what exact curve you're looking for. But if you don't know that, then you just have to be happy with the slope field. All right. Oops. So now that we kind of have a visual of a slope field, what can we do with the slope field? Okay, well, you can either try to draw a sketch with your calculator, or sometimes there are a few things you can do by hand. Let's start with sketching it with a calculator. So here is a nice, easy differential equation. Let's draw a slope field with the aid of our calculator. So move the dx over here. You're left with dy is equal to x minus 5 dx. You can take the integral of both sides, and you're left with y is equal to 1/2 x squared minus 5x plus c. And what we're going to do is we're going to graph this equation and simply put in a bunch of numbers for the c to give us an idea of what this slope field will look like, because your calculator sadly cannot graph slope fields that I know of. So go to y equals here, and we're going to type in 1/2 x squared minus 5x. And I'm going to put in a couple of different c values. So I'll just do plus 0 first, and then type in a few others. Plus 5x minus 7. And I'll do one more, 0.5x squared plus 5x plus 3 maybe. And you could put it as many as you want. That will probably be enough for me to get an idea of what this looks like. Here. Alright, sorry about that. I realized I typed in some equations wrong. They were minus 5x and I was putting plus x. So when I plot these, you can see that's a nice parabola, as it should be. And hopefully you can kind of see the shape of what this is supposed to look like. But we don't know which graph it is, so I'm just going to draw that general shape with dashed lines. Okay? So we're going to have my y-axis, x-axis, and let's see here. It looks like our middle is around 1, 2, 3, 4, 5. And then you can just, the best of your ability, start drawing the slope field. And this is, of course, just a sketch to give you an idea of what that slope field looks like. You're never going to draw a very good one by hand, and thankfully you will never really need to. Okay, so that's about the best I can do by hand. Not very pretty. Computers can do it much better than we can. So you can see that's not something you would ever really do or need to do on a test, or certainly on an AP test. So what can you do by hand that actually looks good and takes some calculation? So let's take a look at that. What can we do by hand? Well, if you're given a graph and a differential equation, what you can do is don't take the integral of both sides and try to see what the graph is supposed to look like. Just plug in some numbers into the slope and draw the slope. So let's pick a point right over here, 1, 1. Okay, so x is 1, y is 1. Well, if x is 1 and y is 1, the slope must be negative 1. And so I can draw a slope of negative 1. Then you pick a different point. Let's go 2, 1. At the point 2, 1, x is 2, y is 1. 2 over 1 is 2, and that will be a negative 2. So this slope will be negative 2. Well, that's going to be negative still, but a little bit steeper than the one right next to it. Okay? If you really want a way to be precise, it'll be negative 2 over 1, so down 2 over 1. It should point to that point right there. So I'm a little off, but pretty close. And then you just start filling in as many as you need to. Now you can see this would take forever to do all of these. And so on a test, you would only usually do like 4 or 5 or 6 little dashed lines. So let's do a couple more. Let's do this one right here. That is the point 0, 1. So x is 0 and y is 1. So x is 0, y is 1. That would be a slope of 0. And so you can start to put together a few patterns sometimes. Whenever x is 0, this whole thing is going to be 0. So all of these points here, the slope is going to be flat. Let's do this point, 1, negative 1. Well, 1 over negative 1, negative 1 over 1 would give me a positive 1 slope there because of the two negatives. So that one would go this way. You could also then do the other points at 1. Those are nice and easy because they're all 1 over 1. And in fact, 2 over 2 would also give you that same slope. 3 over 3 would also give you that same slope. And so these diagonals are all going to be the same. So sometimes you can find patterns that would really fill this in faster. It also helps that we should have seen this before. This is going to be a circle. Let's see, the one more thing I want to talk about with this one are the points on the x-axis. So this one would be the point -1, 0. The y value is 0, and the x value is a number. Dividing by 0 is undefined. We know this is a circle, and so these are all going to be straight up, which are, of course, undefined slopes and undefined lines. I would recommend, if it's undefined, don't put it, because dividing by 0 is a tricky thing. You're safer to just leave them blank. I've seen that on AP tests before. Leave them blank. So you just plug in the x, plug in the y, and then draw a little line that approximates the slope. I've seen that on AP tests a lot, and I'd like you to be able to do it. All right, so there, hopefully you kind of understand what a slope field is and how to make it. Oftentimes you're just doing a couple of points by hand.